Hello and welcome to this solution video. If you like it, please share with your friends, give it a thumbs up and subscribe to Math United. Let's get started with question number 1. The coefficient of x square in the expansion of 1 minus 4x to the power 6 is 12 times the coefficient of x square in this one. So both of them are different. So let's expand them separately. Let me expand 1 minus 4x to the power 6 here and 2 plus ax to the power 5 here, and as a result we have to find the value of the positive constant a. So we'll focus only on x square because they're saying x square here and x square here. So if I say x square, I will get x square because of this 4x squared, right? That means the remaining 4 out of 6, there are 2 and remaining 4 will be with 1. And I made a mistake, I did not write minus 4 here because minus is with 4x, so it has to be here. Though square will not make any difference, but still we should write it. Now, in front of this we should write the number which is the exponent here, c, and this number. These two numbers must match, 2 and 2. And this is n, the exponent of the binomial. This will give us x square. Alright, so 6c2 is 15, minus 4 square is 16, and x square is x square, and 1 to the power 4 is 1. There is no need to write it. And in this here now, we will again do the same thing. Ax will give us x to the power, so we'll give it ax square, and it's positive, so no need to write any sign. 2 will get the remaining 3 out of 5, and here we'll write 5c, and you guessed it right, 2. So 5c2 is 10, and a square will be there, a square, x square will be x square, and 2 cube is 8. And now the coefficient of this 16 times 15 is 240. Yeah, 240 x square. This will be 8 times 10, 80 a square x square. So this is the coefficient of x square. Here in this expansion, this is the coefficient of x square in this expansion, and they said it is 12 times the other one. So 240 has to be 12 times 80 a square. That's what they're saying. And we can find a now. So these two will go down here. So 240 divided by 12 times 80 equal to a square. So this is 3 and this cancels 4. So a square is 1/4, and that gives us a is plus minus square root 104, which is plus minus half, but I will write only the positive one. Why? Because they said positive constant a. So this will be the answer of question number 1. Question 2. The curve y equal to x square, a simple quadratic parent function, is transformed into this. Let me rewrite that one. Y equal to 4x minus 3 square minus 8. This is the one. Okay, describe fully the sequence. Sequence is important of transformations that have been combined, making clear the order in which the transformations have. So keep in mind, always compression or stretch come first, and then comes translation. Okay, so we'll see which one is which now. So let me mark them one by one. This one is vertical stretch by a factor of 4. Is there any compression or stretch in horizontal direction or x direction? No, this has not been multiplied by anything. This square is not with 4. So it is vertical, it is not horizontal. If there is a bracket here and this square was applied to 4 as well, then it would become horizontal. So there is no horizontal. So definitely this is going to be the first vertical stretch by a factor of 4. Now there are two translations here, this and this. So it does not matter which translation you write first. So I'm writing, because this is vertical, so I will write vertical first. This is minus 8. There is a vertical translation, 8 units down. The one which is outside the main function is vertical, just like 4. Minus 8 is outside, so it will be vertically down. That is the translation. And then there will be this minus 3, which will bring it to the right. Normally negative is towards left in a number line, but we'll say right. So it is horizontal, or you can write in place of vertical or horizontal, you can write in the direction of y here and in the direction of x here. But I use the word horizontal translation by 3 units to the right. Question 3a part. Show that the equation 7 tan theta divided by cos theta plus 12 can be expressed as this. So I don't think there should be any problem in this one. 7 tan theta divided by cos theta plus 12 equal to 0. Okay, so first we should do what? We should multiply the whole equation by cos so that this denominator is gone. So let's multiply the whole equation by cos theta. So when it multiplies with this, 7 tan theta is the only expression left. Then cos theta multiplies with 12, it becomes 12 cos theta, okay, equal to 0. Now we can see that there is no tan here. That means this tan must go, and we should be in terms of sine and cos again. So we can write tan theta as 7 sine theta over cos theta plus 12 cos theta equal to 0. Now again we'll have to get rid of this cos theta. You could have done it in one go, but I'm teaching you how part by part we can do this. Alright, so this cos theta multiplies here, it becomes 7 sine theta, and this cos theta cancels with cos theta again, plus 12 cos square theta equal to 0. This cos theta gives us square and 0, but it does not match here yet, isn't it? Because we have 12 cos square and we have 7 sine theta here, but it is, we need sine square, we have cos square here. So we know that sine square theta plus cos square theta is equal to 1. So we can write that cos square theta is 1 minus sine square theta, right? We can rearrange it. Let's change this cos square theta with 1 minus sine square theta, and we'll be there. 7 sine theta plus 12, 1 minus sine square theta equal to 0. And if we open the bracket, it becomes 7 sine theta plus 12 minus 12 sine square theta equal to 0, but it still does not match here correctly because every sign is opposite than the target one. So what will we do? We'll again multiply the whole of it by minus 1 and everything will fall in place. So minus 12 sine square theta times minus 1 will become positive sine square theta. That's what we want first. Then this 12 times minus 12 will be minus 12, so we'll write minus 12 here. Then this 7 sine theta will be negative sine theta and equal to 0 times minus 1 is 0. Done. This is what they wanted us to show. There must be a second part which is here. So hence solve the equation this equal to 0. So they match, perfectly match. This was with us earlier, which is equal to 0. That means we would like this to be equal to 0 from 0 to 360 degrees. So let's do it here. So in place of this expression, this one, left hand side, we'll write the one we transformed this into 12 sine square theta minus 7 sine theta minus 12 equal to 0. 12 times 12 is 144, and can we get 7 out of that? Yes, we can. 144 has two factors, 16 and 9, and their difference is 7. So I can break the middle term. You can use quadratic formula if you want. I'm doing splitting the middle term. So 12 sine square theta minus 16 sine theta, which is coming from here, plus 9 sine thetas minus 12 equal to 0. So minus 16 plus 9 is again minus 7. So I have split the middle term into two parts. And now these two have 4 in common and sine theta. 4 sine theta, 3 sine theta minus 4. And what do we have? 3 common here. Plus 3 sine theta minus 4. Both parts have same thing. So 3 sine theta is common. We left with 4 sine theta plus 3 equal to 0. So now we get two solutions out of this. This one will give us 3 sine theta minus 4 equal to 0. So sine theta equal to 4 sine theta equal to 4 over 3 positive. Yeah, and this one gives us similar way, sine theta equal to negative 3 over 4. So they are negative reciprocal of each other. These are the two ones, but we want angles between 0 and 360 degree. Let's focus on this one first. So let's do it here. If we have 4 quadrants and sine is positive in this quadrant and this quadrant. So these are 2 quadrants where we will see now theta is sine inverse 4 over 3. But unfortunately sine cannot be more than 1. So this one is rejected. That means we'll have to go with this one. So again, sine is negative in these 2 quadrants. There's negative here, right? So now we'll write theta equal to sine inverse 3 over 4, not negative, because we have already decided quadrants. There's no need to write negative here, otherwise we'll get a wrong answer. So sine inverse 3 over 4. 48.590, so I write 48.6 to 1 decimal place degrees, right? So this angle, this small angle will be 48.6. This is also 48.6. So the first answer, theta 1, let's write theta 1. First answer will be starting from 0, and this is 180 plus 48.6, which is 228.6 degrees. Second answer will be continuing from here and reaching this point, this line, which is 48.6 less than 360 degrees, less than a full circle, right? So it will be 360 minus 48.6, which is 311.4 degrees. These are the two answers of the given equation. Question 4. The function f is defined as follows. Find the expression for the inverse of x. Alright, inverse of fx. So it will be, let's rephrase it. Y is equal to square root x minus 1. Okay, this is our function, this one. Now to find the inverse, we exchange the spaces of y and x. That means y becomes x and x becomes y. Now I need to isolate this y to get the inverse function. So let's keep it here, and we'll get x plus 1 on this side. And to get rid of square root, we square both sides. So this square root and square cancel. We get y is equal to x plus 1 square. And this y, new y after inverse, will be the inverse of the function, original function, which is x plus 1 square. This is the inverse. Now the diagram shows the graph of gx, okay, where gx is this, and it is for all real numbers. Okay, state the range. So range is the value of y. We can see that this y value does not reach 0, and obviously so, because 1 divided by some number will never give you a 0, right? So we can see that the range is between this y value and 0, and 0 is not included. Okay, so it will be 0 not included, means we'll not write an equal mark here. X is equal to, now what is the y value when x is 0? This is the y-intercept, isn't it? So let's see, g0 will be 1 over 0 square plus 2, which is half. So this y-intercept is 1 over 2. So from 0 to half, half is included but 0 is not. This is the range. Okay, and explain whether inverse of g exists or not. So you can see that if I draw a horizontal line through this, it crosses at 2 places. That means it is not a one-to-one relationship here in this. For an inverse to exist, we should have one-to-one relationship. So we'll say no, G inverse does not exist as it in place of it, again G is not a 1-to-1 function. Or you can say that the horizontal line test fails in this one, so the inverse of it will have vertical line failure. That's why there is no inverse. Okay, the function h, the different function h, okay, is defined as, let me write this as h x is equal to 1 over x square plus 2. Isn't it the same as the previous one? Yes, same as gx, but it was for all real numbers, and this one is for greater than 0 only. That means only this part from here to here, so that it has an inverse and it is actually a function. Okay, so from here to here, that is our hx function. Okay, solve the equation h of x. Okay, so what was fx? Fx was square root x minus 1, square root x minus 1. So h of x, which is same as h of fx, which will be same as h of square root x minus 1, right? So in this hx, we'll substitute each x, which is the only this x, by this. So which will be h of x 1 over square root x minus 1 square, this one, and plus 2. I hope you understand. This x individually was substituted by the square root x minus 1 from fx. Okay, and they say it is equal to f25 over x. So fx was square root x minus 1, and f 25 over 16 will be square root 25 over 16 minus 1, which is 5 over 4 minus 1, which is 1 over 4. So it is 1 over 4, and we have to solve it. So let's continue here. 4 multiplies with 1, cross multiplies, so 4 is equal to, multiplies here, square root x minus 1 square plus 2. Okay, let's bring 4 to this side, so it becomes 0 equals to, and expand this, so minus 4, this 4 becomes minus 4 on the right side, then we have plus 2, and this will expand. This will be what? I'll use this identity, a minus b whole square is equal to a square plus b square minus 2ab. So a square is square root x square plus b square, and minus 2 times, and I should not write this minus, if the identity has plus, then we should write plus, 2ab. So 0 is equal to minus 4 plus 2 is minus 2, and minus 2 plus 1 is minus 1. Okay, this square root and square cancel, so plus x. So this is taken care of, 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 minus 2 square root x. This becomes our equation, which I will rearrange now. Let me write it here. X minus 2 square root x minus 1. And to make it quadratic, let's assume that square root x is equal to t. So x square both sides, x will be t square, right? So this becomes 0 equal to t square minus 2t minus 1. Okay, and let me use quadratic formula to solve this. T will be equal to minus 2 plus minus 2 square minus 4 times AC over 2 times 1. So it becomes positive 2 plus minus 4 and plus 4, 8. Square root 8 over 2, which is 2 plus minus, square root 8 will be 2 square root 2 over 2. Yeah, so 2, all of them are 2, so it will be, answer will be 1 plus minus square root 2. Yeah, but that is t. Our original one was t was square root x, so that's what I will use now. So square root x is equal to either 1 plus square root 2 or equal to 1 minus square root 2, and I'll square it to get the value of x. I'll get two answers. So x is equal to 1, again I'll use the same identity but this time plus and plus here, so 1 plus 2 plus 2 square root 2, 3 plus 2 square root 2. Is this positive? X is positive. Okay, what about this? X equal to 1 plus 2 minus 2 square root 2. So that is 3 minus 2 square root 2, where x is greater than 0, which was the condition right in this question. So this is okay. Here it comes in this format: a plus square root b, a square root b, rather a plus b square root c, that was the one, right? So it comes out to be a is equal to 3, b is equal to 2, c is also equal to 2. And in this one, 3 minus 2 square root 2 is about 0.2, 19 or something, okay, which is positive, which could have been accepted. But you look here, square root x, this came about after squaring. If I say 1 minus square root 2, you'll see it is 0.41. Okay, and square root of a number, if it is a negative, it should not be acceptable, so we will reject this one. So these are the only answers we have. Question 5. The first and the second term of an arithmetic progression AP are tan theta and sin theta respectively. Theta is an acute angle basically, right? Given that theta is 1/4 of pi, find the exact sum of first 40 terms of the progression. It's an AP. Okay, so A1 is tan theta, A2 is sin theta. That means difference between them, D, common difference, is second term minus first term. Okay, now they're asking us to find the exact sum of first 40 terms. So the sum of an AP is this, n over 2, 2a plus n minus 1 d, right? So S40 will be 40 divided by 2 times, first term is tan theta, 2 tan theta, plus 40 minus 1, 39, and d is sin theta minus tan theta. Okay. Now we have to simplify this to get exact sum, and we have to substitute theta is 1 over 4 pi. So S40 equal to 20 2 tan pi by 4 plus 39 sin pi by 4 minus tan pi by 4. Okay, which will be 20. Tan pi by 4 is 1, so we just left it 2 here, plus 39 sin pi by 4 is square root 2 over 2 minus tan by 4 is 1 again. Okay, so this is what will create trouble. So how can we do this? Okay, let's write 40 here. 20 times 2 is 40, 20 times 39 will be 780, and this will be square root 2 minus 2 over 2, right? 2 will multiply here, we can write this 2 over 2, that's how it is. This 2 will cancel with this one, 390. So can we open the brackets now? 40 plus 390 square root 2 minus 390 times 2 minus 780. Okay, so the sum comes out to be how much? 390 square root 2 minus 740. This is the exact, this is the exact sum, right? 390 square root 2 minus 740 is the sum of first 40 terms. Let's move on to the second part, B. The first and second terms of a GP now are tan theta and sin theta. So A1 is tan theta, A2 is sin theta. That when common ratio R will be sin theta second term divided by the first term. Okay. Okay, where they've given a range also. Theta is between 0 and 1 over 2 pi. It's an acute angle. Find the sum to infinity of the progression in terms of theta. Sum to infinity. Sum to infinity is the first term over 1 minus r, the common ratio. And we have everything. A, tan theta is our first term. And the common ratio is 1 minus sine theta over tan theta. So let's make it a fraction again. So it will become tan theta over tan theta. We can write it 1, right? So that the denominators here are same. So this gives us tan theta divided by 1. Yeah, this tan theta can be written as tan theta divided by 1. And then we have tan theta minus sine theta, and both of them have same denominator, tan theta. And now we can multiply the first and fourth, second and third. This is how we solve a fraction by a fraction, and this was not a fraction tan theta, I made it tan theta over 1. So it becomes tan square theta over tan theta minus sine theta. This is the sum to infinity in terms of theta. Okay. Part 2 is also there for B. Given that theta is 1/3 pi, find the sum of the first 10 terms of the progression. Okay, so again A1 was tan theta, A2 was sine theta, R is sine theta over tan theta, and we want sum of first 10 terms. Okay, and the sum of first term is A R is this. Okay, this 1 minus, then 1 minus r to the power n over 1 minus r. So in this case S10 will be A. The first term is tan theta, 1 minus r sine theta over tan theta, their power to the power n, which is 10 in this case, divided by 1 minus sine theta over cos theta, no, tan theta. Okay, now they have given the value of theta, which is 1/3 pi. That's what we will substitute now. Tan pi by 3 okay, 1 minus sine pi by 3 over tan pi by 3 to the power 10, this to the power 10, not 1. Okay, divide by 1 minus sine pi by 3 over tan pi by 3. Let's evaluate this here. Tan pi by 3 is square root 3. 1 minus sine pi by 3 is square root 3 over 2. And tan pi by 3 is again square root 3. And I can write it divided by 1. So that it becomes the format I did earlier, a fraction divided by fraction, so that I can multiply first and fourth, second and third. Okay. And to the power 10. In this, they will cancel because both have same numerator, so they will cancel out. So I will take care of this later. It becomes 1 minus again square root 3 over 2 divided by square root 3 over 1, and they cancel again. So this was a denominator. It will remain denominator, but this denominator will become numerator if it multiplies here, right? So square root 3 1 minus, it is 1/2 to the power 10 divided by 1 minus 1/2. Okay, square root 3, and this will be 1/1024. 2 to the power 10 is 1024. You can use a calculator. I'm using my mental math. So 1023 over 1024 divided by 1 minus half is half. Alrighty, this 2 will multiply here, so it will become square root 3 times 2046 divided by 1024. And they are both even numbers, so they can divide by 2. So square root 3, 10, rather let me write 1023 first. 1023 square root 3 divided by 512. If I divide both of them by 2, and this should be the answer. Question number 6. The curve with equation this 2x minus 8x to the power half has a minimum point at A. So suppose this is the curve and this is the minimum point A. Okay, and intersects the positive x-axis at B. So let's say that this is x-axis, this is y-axis, and it is intersecting positive x-axis at B. Find the coordinates of A and B. So these A and this B. So this is actually the x-intercept we are saying, which is on positive side of x-axis, and this is the minimum point. So let's talk about the minimum point first. For minimum point, y prime, the differentiation of y should be equal to 0, right? So let's differentiate this. So dy over dx equal to 2 minus half and 8 x to the power minus half. Yeah, half minus 1 minus half. So this 2 and 8 cancel. So it comes out to 2 minus 4 over square root x. This is the differentiation. Okay, now this is equal to 0. The differentiation should be equal to 0, so I'm making this equal to 0. So let's make it bring it to the left side, and it becomes positive 4 over square root x equal to 2. Yeah, and let's cross multiply. Square root x comes there and 2 comes down. So 4 divided by 2 is square root x. 2 is equal to square root x. So square both sides, x is equal to 4. They said find the coordinates of A and B. And the x coordinate of A is 4. So it is also on the positive side. This A is not on the negative side, it's positive. This was just an example, okay? So let's find the y coordinate now. So y is equal to 2x, x is 4, minus 8, 4 to the power half, which is 8 minus 8 times 2. Yeah, so minus 8. 8 minus 16, yeah, which is minus 8. So the coordinates of A are 4 minus 8. Let's talk about B, which is x-intercept. So x-intercept, at x-intercept, y is always equal to 0. So I'll put this y is equal to 0, and I'll get the x coordinate equal to 2x minus 8x to the power half. Let me take 2 and x to the power half common from them. So 2x to the power half taken common. So 2 is out. Out of this x half power half is out, so x to the power half is remaining here, minus out of 8 2 is out, so 4 left, and it is already okay out. That's it. Okay, so this will give me 2x to the power half equal to 0, which gives me x equal to 0. This will give me x to the power half minus 4 equal to 0, which is x to the power half equal to 4. Square both sides. So x is equal to 16. So the x coordinate of this is 16. So the coordinates of B are 16, 0. Alrighty, let's go to the next part, which is the B part. The diagram shows the curve with equation this. So they have made our job easy. They have already drawn it. And the line AB. So this is minimum, and this is the x coordinate, x intercept. So let me write here. It was 16, 0. This was 4 minus 8. Okay. It is given that the equation of AB is this. This line AB is this. Okay, find the area of the shaded region between the curve and the line. Okay. So this is the shaded area I want. So let's draw vertical lines from A and B. Okay. So if you look at this, isn't this a triangle? This line and this line and this line. This is a right angle triangle, correct? So my plan is that I will find the area above this curve by integration and subtract the area of this triangle from that curve. Yeah. So let me find the area of the triangle first. So I will write area of the shaded part will be area above curve minus area of triangle. This area above curve will be negative because it's below x-axis. It will be negative, so I'll just absolute that one. I will make it to positive. I'll change it to positive. So area of triangle first. Area of triangle. Because it's a right angle triangle, I can instead find half base times height, which is half. Base is this one, which is here. It is 4. Here it is 16, so base becomes 12. Height is the y coordinate of this, which is minus 8, but I will take it positive 8. So it comes out to 48 unit square. So this is done. This is left. So area and above curve will be from 4 to 16, and the curve is the area of this function is 2x minus 8x to the power half dx. Yeah, obviously this answer will be negative, but I will absolute it. Okay, so integration of 2x is 2x square over 2 minus 8x half plus 1 over half plus 1 plus c, and from 4 to 16. Okay, so I'll cancel this 2 and 2, substitute 16 first. So 16 square minus, this is be 3 over 2, so 8 times 3 over 2, yeah, because it's a denominator, so it will become 2 over 3. Then 16 to the power 3 over 2, this will be 1. I'm ignoring c this time, minus 4 square minus 8 times 2 over 3, 4 to the power 3 over 2, 256, and 16 over 3, and this will be 64, minus 16 times 64 over 3 minus 16 plus this negative and this negative make it plus, so 16 times 8 over 3. Okay, 256 minus 16 will be 240. 16 times 64 will be 1024. 1024 plus this minus is here. Okay, 128 over 3. Okay, so this comes out to be how much? 240 minus, it will be 896 over 3. That comes out to be minus 100, 720, 190, 176 over 3 units, but we'll have to absolute it. Okay, now area of the shaded part, we got 48 for the area of triangle, so it will be 176 over 3 positive minus 48, which will be 144, so 32. Yes, 32 over 3 units. You can convert it to decimal if you want. This should be the answer. Question 7. The equation of a circle is this. The line with the equation y equal to 2a minus x is tangent to the circle. So let me try to draw a circle first. Okay, let's say that this is the circle and this is the tangent. Okay, the equation of this tangent is y equal to 2a minus x. And now this is the equation of the circle. It means that the x coordinate of the center is 6. Yeah, because of x minus 6 squared. The y coordinate of it is minus a, because of this plus a, right? And the angle between them will be 90 degree. From tangent and radius, the angle will be 90 degrees. Okay, let's call the coordinates of this point as m, n. So whatever is the gradient of this radius will be a negative reciprocal of the gradient of this particular tangent, and the gradient of this tangent is minus 1. Can you see? Because we know that the equation of a line is y equal to mx plus c. The coefficient of x in this case is minus 1, and the coefficient of x is always the gradient. So the gradient of this one is minus 1. That means the gradient of this radius will be plus 1. And how do we find the gradient of this radius? It will be the gradient is y2 minus y1 over x2 minus x1. Yeah, so it will be n minus minus a over m minus 6. And since this mn is also falling on the line, it means that the n is 2a minus m. I replaced x by m and y by n. So I will replace that here. So in place of n, I will put 2a minus m. So and this was gradient was equal to plus 1, right? So n is 2a minus m plus a. Why plus a? Negative negative, it gives me plus a over m minus 6 equal to 1. And because of the cross multiplication, we'll get an equation here, which is 2a minus, rather 3a, because 2a plus a will be 3a. 3a minus m equal to m minus 6. Yeah. Let's bring this m to the right side and 6 to the other side. So it becomes 3a plus 6 equal to 2m. And I'll isolate m in this case. M will be 3a plus 6 over 2. So I got n and m in terms of a, but this m should also go. So let me also write n in terms of a. 2a minus m. M is this. So I will write 3a plus 6, which is in bracket, right, over 2. And if I simplify this, it becomes 2a, rather 4a now, because we need to have same denominator. So this 2 will multiply here, so it will become 4a over 2. 4a minus 3a minus 6, because this minus is both, divided by 2. So n comes out to be a minus 6 over 2. Okay, both of them are in terms of a now. And the purpose is that we've been given equation of circle here. And this m and n both, m and n, this point is also on the circle. So I can substitute m and n in this equation also. X minus 6 is square, so it will become x is m minus 6 square plus y plus a. Y is n in this case plus a square equal to 18. And now we have m and n both in terms of a. I can substitute here. So it becomes 3a plus 6 over 2 minus 6 square plus a minus 6 over 2 plus a square equal to 18. So if I simplify this, 2 times 6 is 12 again. So 3a plus 6 minus 12 over 2 square plus a minus 6, 2 multiplies here, 2a plus 2a over 2 square equal to 18. So this becomes 3a minus 6 over 2 square plus a plus a. Okay, they become exactly same. So since they are exactly same, I can write them as 2. 3a minus 6 over 2 whole square. Both of them are same, so I added them, equal to 18. So can I cancel this? This will be 2 square, right? 2 square 4. So this 2 will cancel with one of the 2's. Let me not do it here. So it will be 3a minus 6 square will be equal to 18 times 4 divided by 2. Let me explain why. This 2 square will become 4, this one, and 4 multiplies with 18, and this 2 comes down. So cancels out also. So I will expand this now. 9. 9a square plus 36 minus 18, 36. A equal to 18 times 2, 36. Wow, 36 and 36 may cancel because both of them are positive on each side. And I can take 9 common, a also common here. So what is remaining here? A. And here just 4 because 9 out of 36 is out. So 4 and a is already out. So a minus 4 equal to 0. And that gives us two answers. A equal to 0 and a is equal to 4. This will give me a equal to 0. This will give me a equal to 4. So I got my two possible values of a. That's what they're asking, right? Find the two possible values of a. Done. Next part says for the greater value of a, which is 4. So that means they are trying to tell us a is equal to 4. For the greater value of a, find the equation of the diameter which is perpendicular to the given tangent. Okay, so I had a circle. I had this diameter and the coordinates were 6 and a, right? 6 minus a. So 6 minus 4 are the coordinates of the center. This is the tangent. Okay. Find the equation of the diameter. Okay, this diameter. Okay. So equation of any line, be it diameter or something, is y minus y1 equal to mx minus x1, right? Y is general y, so y remains y, but y1 and x1 are the coordinates of any point on the line, and we know this point as well as mn now, this point also. We can take any one of them, but I'll take the one which is clearly known to us, 6 and minus 4. So this will be minus 4 here equal to m. We know the gradient was plus 1, right? X minus 6. So it is y plus 4 equal to x minus 6. So let's bring this 4 here also. So y remains here. It becomes x minus 6 minus 4. So finally our equation of the diameter will be x minus 10. That's the equation of the diameter. Question 8. The diagram shows a symmetrical plate. Length of BC is 2 centimeter. They have given here. Each of the two sectors of radius are centimeter. Okay, both of them are congruent. And we see they are equal 13 radians. Not 13 radians, 1 by 3 radians. This is a mistake, so I'll correct it. 1 over 3 pi radians. They have given already here. It is given that radius is 0.4. Show that the length EF, this one, is 2.4 centimeters. Okay, so they are saying radius is 0.4. So this line is 0.4. If I somehow find this length from here to here, this length, okay, same will be the length here, this length. So these two lengths I will add to 2 centimeters and I'll get the length of EF, the one they are asking for. So basically I have to prove that this is equal to 0.2 basically. If this is 0.2, this is 0.2, both of them will add up to 2 centimeter with 2 centimeter and we'll get 2.4 centimeters. So how can I do that? So if this is 1 over 3 pi, so let me redraw the triangle here. The angle outside is 1 over 3 pi, and if this is 90 degree, right, this is pi by 2 and this will also be pi by 2. So 1 over 2 pi minus 1 over 3 pi, if I do it, I will get 1 over 6 pi. So the angle inside this is 1 over 6 pi, right? 1 over 3 pi is 60 degrees, 1 over 6 pi is 30 degrees, total 90 degrees. That's how I got it. Okay, this is also 90 degree. And this is 0.4 centimeter, this one, 0.4. So I can get this length now. How? Tan 1 over 6 pi, not tan, because we have opposite side and hypotenuse. So we should use sine. Sine 1 over 6 pi is equal to, let's call it y. Y divided by hypotenuse. How much hypotenuse? 0.4. Okay. Now sine 1 over 6 pi is 0.5 is equal to y over 0.4. They cross multiply. So 0.5 multiplied by 0.4 is y. So y comes out to be 0.2 centimeters. That was our target. So this is 0.2, this is 0.2. So EF is 0.2 plus 2 complete plus 0.2. That comes out to be 2.4 centimeters. Second part says find the area of the plate, give your answer correct to 3 significant figures. So what will I do? I'll find the area of the triangle I just highlighted. I'll double it. I will get this one also, right? So area of this particular plate will be equal to 2 times area of triangles. Then I will find this rectangle's area plus the area of rectangle. Then I'll find the area of this sector, which is exactly as this sector, so 2 times area of sectors, and I will get the area of the plate. Okay, so let's start with this area of triangle. Is equal to half base times height. So, or why should I use half base times height? I can use half AB sine C, this formula. Okay, so I know two sides, which is 0.4 and 0.2, right? Only thing I need is the angle between these two sides to get this angle C. I know this is pi by 2, this is 1 over 6 pi, so this will be 1 over 3 pi, because the sum of three angles of a triangle is pi. So I'll subtract 1 over 2 pi, 1 over 6 pi from pi, and I get 1 over 3 pi here. So the area of the triangle is half. Side 1 is 0.4, side 2 is 0.2, and the angle between them is 1 over 3 pi, so sine of that angle 1 over 3 pi. So this comes out to be 0.2. 0.2 times 0.2 is 0.04 times sine 1 over 3 pi is square root 3 over 2. So I'll evaluate this later. I'll add this later with others. Let's go to the rectangle. Yeah, the rectangle's area will be length times area of rectangle will be length times width, right? Length is already known to us, 2 centimeters. Width we don't know yet. We can find that here. This particular length we can find by Pythagorean theorem, or we can again use trigonometry. So let me use trigonometry, okay, to find this. Let me do it here. I have some space. So let's call this length x. So x divided by 0.4 will give me cos 1 over 6 pi. Okay, x over 0.4 cos 1 over 6 pi. Okay, and x comes out to be 1 over 6 pi is square root 3 over 2 again times 0.4. This is the length of the height of the rectangle, which is height of the triangle as well. Okay, so 2 we already know the length. Now width came out to be how much? 0.4 square root 3 over 2 times 0.4. So that comes out to be 0. Okay, this 2 and this 2 can cancel. So 0.4 square root 3. This is the area of rectangle. Now left is the area of sectors, and that is also we have to twice. We have to do it double. Okay, and we have double area of triangle also later on. Okay, area of sector is half theta r square. Yes, this is the area for any sector. Half theta angle is 1 over 3 pi. Yes, 1 over 3 pi they have given. So 1 over 3 pi, and radius is 0.4 square. So that comes out to be 0.16 pi over 6. Yes. Okay. Finally, total area. Area of plate will be 2 times area of the two triangles, which was 0.04. It was the area of one triangle, right? Square root 3 over 2. So this 2 and this 2 cancel. Plus area of rectangle, which came out to be 0.4 square root 3. Then we have two sectors. One sector was 0.16 over 6 pi. Put them carefully in a calculator and you get your answer. What I got was 0.929653. Many digits after this. I will round it off to 0.930 centimeter square. This is the area of the plate. Moving ahead. B, it is given instead that the perimeter of the plate is 6 centimeters. Okay, I'll have to copy or bring that down. Okay, copied. So now we will put, because we want to find radius, we'll put everything in terms of radius. So perimeter is 6. So 6 is equal to this line first, 2 centimeter. Then we will add this radius and this radius, which is 2r. Then we will add this arc and this arc, which is r theta. So 2 r theta. r and theta is given to us 1 over 3 pi. So done. Now again I have to find these two. So this length, since this is 1 over 3 pi, this is 1 over 6 pi. So let me redo the same thing again. If this is 1 over 6 pi and this is a radius, this is radius, this one. So what will be the length here? So it will be sine theta again. Sine 1 over 6 pi is equal to, let's call it z this time. So z divided by r. So z comes out to be, because this is half, 0.5 r. So we will add this length as well as this length, which is twice of 0.5 r. And then we have 2 in middle, this 2. Every length of the perimeter has been taken care of. Our equation is in terms of only r, so we'll get it now. So 2 plus 2 is 4. It will go to the other side. Okay, done. 2r, and this is just 1r. Can you see? This one, 2 times 0.5 will be 1, so 3r plus 2 over 3 pi r. So 2 equal to r taken common, 3 plus 2 over 3 pi, and r will be 2 divided by 3 plus 2/3 of pi. Just put this in a calculator and you'll get your answer. By the time I do this, I will again remind you to like this video, share with your friends, and subscribe to Math United. What I'm getting in 3 segment figures is 0.393 centimeters. Question 9. A function f is such that its derivative is this. For x is all elements of, belongs to all elements of real numbers. So it's like this. Okay. Determine the set of values of x for which fx is decreasing. When a function decreases, f prime x, which is differentiation, has to be negative, less than 0. And that's what they're asking. So this has to be less than 0. 6, 2x minus 3 square minus 6x is less than 0. So let's open the bracket now. 6, 4x square plus 9 minus 6 times 2, 12x minus 6x is less than 0. So can we divide it by 6 all the terms so that it becomes easier? So 4x square, this cancels out, plus 9 minus 12x minus x, just x, is less than 0. So it becomes a quadratic inequality. 4x square minus 13x plus 9 is less than 0. Can we get its roots? Yes, we can. I'll split the middle term. You can use quadratic formula if you like. Middle term will be 4x square minus 4x minus 9x plus 9 less than 0. 4x taken common, x minus 1 minus 9 taken common, x minus 1. So it comes out to be x minus 1 and 4x minus 9 less than 0. We did not do any negative. Okay, so roots, the two roots were, if it was a polynomial, it would cross x-axis. So roots are x equal to 1 from this one and 9 over 4 from this one. Okay, so if I look at the graph, because this leading term is positive, it will open up. This root is 1 and this one is 9 over 4, which is 2.25. Yeah, right. Now we want less than 0, and less than 0 means the value should be negative, and the value is negative here for the function. So answer will be 1 is less than, x is less than 9 over 4. Okay, let's go to the next one. Given that f1 is minus 1, find fx. Okay, so basically from the derivative they are asking us to find the original function, and we'll have to integrate it to find the original function. So we will integrate 6 2x minus 3 square minus 6x with respect to x. Okay, since this is linear, so it will be easy, not a big deal. So 6 2x minus 3 cube, it will go up by 1, divide by 3, and further divide by the differentiation of this. Differentiation of 2x minus 3 is 2, because minus 3's differentiation will be 0, so we'll not do it, that's 2. Minus 6x square over 2 and then plus c. 6 and 6 cancel, so it comes out to be 2x minus 3 cube minus 3x square plus c, that is fx. However, it is not complete yet because c's value is to be found out, and they've given us f1 is minus 1. So f1 will be 2 times 1, 2, minus 3 cube, minus 3, 1, minus 1 they said. So did I do that here? No, I did not. So it will be plus c equal to minus 1. Yeah, so minus 1 cube is minus 1, 3 times 1 will be 3, so minus 3 plus c equal to minus 1. C is minus 1 and this will be minus 4, which becomes plus 4 there, so c is equal to 3. So our equation, find fx, final fx will be this one, 2x minus 3 cube minus 3x square plus 3. That's the function. Question number 10. The equation of a curve is this: y equal to 5 minus 2x to the power 3 over 2 plus 5, and point P is moving along the curve in such a way that the y coordinate of P is decreasing. Okay, so y coordinate of P is decreasing. So dy over dt is minus 5. Because it's decreasing, so negative. Find the rate at which x coordinate is increasing. So dx over dt is what? If y is 32. Okay, so first we will differentiate the main equation, which will give us dy over dx, the differentiation of this one. So 5 minus 2x has a power 3 over 2, so 3 over 2 will come in front, and then the power will go down by 1, which is, we will leave 1 over 2 here, and then differentiation of the contents of this 5 minus 2x, which will differentiation will be minus 2. Differentiation of 5 is 0, no need, but differentiation of minus 2x will be minus 2, that will multiply here. Differentiation of this 5 will also be 0, so no need to do anything here. So we can cancel this 2 with this 2, but negative will remain. So dy over dx is equal to minus 3 5 minus 2x to the power half. Now I will introduce time here. So dy over dt, I'll divide both up and down by dt. dy over dt is given to us minus 5, so I'll write minus 5 over dx over dt equal to minus 3 5 minus 2 times x is not known to us, but I'll give some space for it. First thing first, these both are negatives, so we will cancel them so that they don't create any trouble in between. This is multiplying, so we can cancel. Now this x is needed. We know y, but we don't know x. We can find the corresponding x coordinate when y is 32 by placing it in the main equation. So main equation, y is 32 equal to 5 minus 2x to the power 3 over 2 plus 5. So this 5 comes to the other side. 32 minus 5 is 27 equal to 5 minus 2x to the power 3 over 2. Now our next target is to remove this 3 over 2. So I will give one exponent to both sides, 2 over 3. Okay, so that this 3 over 2 and 2 over 3 cancel, their multiplication will be 1. Okay, 2/3 power of 27 is 9, and we are gone with the exponent here, so we are just 5 minus 2x here. So 2x equal to 5 minus how much? 9. So x is equal to minus 4 over 2, which is minus 2. This minus 2 will write here in place of x. And now we have everything, just we need to find dx over dt. So dx over dt will come here, and whatever we're getting will come down. So here 5 over 3 is already there. So let's see what happens here. 5 minus 2 times minus 2 is plus 4. Bad mass, according to bad mass, will multiply first. So 5 plus 4 is 9. And 1 over 2. 9 to the power half, which is square root of 9, is 3. So positive 3 equal to dx over dt cross multiplied, and which comes out to be 5 over 9 units per second. Okay, next part, B. Point A on the curve has y coordinate 32. So A is a point whose y coordinate is 32, and we just got that the x coordinate is minus 2. Point B on the curve is such that the gradient of the curve at B is minus 3. Gradient, which is nothing but dy over dx at B is minus 3. Okay. Find the equation of the perpendicular bisector of AB. So let's say that 3 is this one, and let's say this one. So this is minus 2, 32, and suppose this is B. I'm just randomly drawing, okay? It doesn't mean that this is the right one. Its gradient is positive 3. No, negative 3. Okay. Let me change it. It doesn't look like negative, right? So I will do this way, and this is negative 3. Suppose this is B, and gradient here is negative 3. Okay, so dy over dx we got earlier was what? This. Minus 3, 5 minus 2x to the power half. What was that? Minus 3, 5 minus 2x to the power half. Minus 3, 5 minus 2x to the power. They said this is equal to minus 3. Okay, that means this minus 3 and this minus 3 can cancel out. So we are left with 5 minus 2x to the power half equal to 1. And we'll square both sides to get rid of this half. 5 minus 2x is equal to 1. So minus 2x equal to 1 minus 5, which will be x is equal to minus 4 over minus 2, 2. X coordinate is 2 here. So what will be the y coordinate? Let's find y coordinate here by substituting in the main equation. What was that? Y equal to 5 minus 2 to the power 3 over 2, right? 5 minus 2x. 5 minus 2x to the power 3 over 2 plus 5. This was the y coordinate. So 5 minus 4 is 1. This is 1 whole of this is 1 plus 5, 6. Y equal to 6. So it comes. All right. Now we wanted find the equation of the perpendicular bisector of these two. So this is AB. We want its equation perpendicular bisector. So perpendicular bisector is a line whose equation will be y minus y1 equal to mx minus x1. We need a point on that perpendicular bisector whose coordinates will be x1, y1. That means this point here. And this will be exactly between them, right? So x1 will be the x coordinate of one point plus x coordinate of other point divided by 2, which is 0 in this case. y2 will be, sorry, not y2, y1 will be 32 plus 6, both positive, yeah, divided by 2, 38 divided by 19. So we got the point. The coordinates here are 0, 19. Now we need m, the gradient. We know the gradient of, we can find the gradient of AB. So gradient of AB will be y2 minus y1 over x2 minus x1. This is how much? 32 minus 6, 26 over minus 4, which is minus 13 over 2. Okay, so the gradient of bisector will be the negative reciprocal of minus 13 over 2, 2 over 13. So 2 over 13 is the gradient. Y is minus the y coordinate is 19. X minus x coordinate is 0. Okay, so becomes easy. 13 multiplies with both of them, so 13y minus 247 equal to 2x. And the format they want is this, ax, so 2x will remain here. Let's write 2x. 13y will come to the right, minus 13y plus 247. They change the sign, equal to 0. I brought these to the right and then I wrote this way. This is the equation of the perpendicular bisector.